So we're gonna keep trucking on since you haven't seen me in a while. Hi guys. So I figured I'd say hi so you know it's really me and I'm fine. So still in the classroom, still teaching you guys. So we're still trucking no matter what. All right. So last class we talked about water. We talked about how water can act as an acid or a base and then it can react with itself, and we wrote a Kw. You can see it right here. We wrote our Kw equation and how the concentration of the acid ion, H3O+, and the base ion, OH-, relate to each other when it's neutral, when it's acidic, when it's basic. So now let's do a problem. So calculate the hydronium and hydroxide ion concentrations at 25 degrees Celsius in a 6 molar aqueous sodium hydroxide solution. All right, so like we always do at every problem, what am I looking for? So it says the hydronium and hydroxide concentration. So the concentration of hydronium is my H3O+, and the concentration of my OH-. Okay, and then what did they give me? Let's see, they said 25 degrees Celsius, and then I have 6 molar aqueous sodium hydroxide. So sodium hydroxide. All right, so I need to know how much H3O+ I have and how much OH- I have. All right, so let's see. So they gave me temperature, which temperature, okay, does that relate to concentration? Maybe. But they gave me a concentration, and I'm trying to find concentration. So I'm like, what does this mean? So it says 6 molar NaOH. So what I need to know is, well, what do I have? What is NaOH? So here, this is where you can go to the very beginning of our slides, back to that table at the very beginning. These two tables, you could go back and look at these tables to see if you could find NaOH on the table, or if you were in class and you weren't doing this online, you'd have to have that table memorized. You'd have to find it in your head. So from the table, we found that NaOH is a strong base. So what that means is that when it separates, when it ionizes, I get 1 Na+ and 1 OH-. So what that means is if I have this concentration, because it's a 1-to-1 ratio, I also have this concentration. So what that means is they tell me this answer in the problem. I just have to know that they told me that. So my OH- concentration is 6 molar because it's a strong base solution. All right, now I have to figure out the other one. I have to figure out the hydronium. So I've used the 6 molar to find OH-, and I have the hydronium. I don't have anything else. So I gotta figure out H3O+. I have OH- now, I need H3O+. So I need something that relates the two things. The thing that relates OH- and H3O+ is my Kw. This guy, it relates OH- to my H3O+. Because the Kw is a certain value at 25. That's why they gave me the temperature. Because they're telling me at room temperature, and then I know at room temperature what the Kw is. Or you could just go back to this chart. So Kw is equal to the H3O+ concentration times the OH- concentration. So I plug in what I know. So at 25 degrees Celsius, this is just, we just say 1 times 10 to the negative 14. H3O+ is what I'm looking for. OH- is 6. Divide that over, and you get your H3O+ concentration to be 1.7 times 10 to the negative 15 molar. So now you have H+ and OH-. And the H+ should be really small because this is a strong base. So you should have mostly the base ion, just a little bit of the acid ion. Because remember, there's that auto-ionization that occurs within the reaction itself, the waters. All right, so this is the way that I can relate OH minus to H3O plus. But you might be saying, well, if somebody gave me this as my H3O plus concentration, they said, is 1.7 times 10 to the negative 15 for H3O plus, is that a strong acid, a weak acid? Is that even an acid at all? Like, how do I know what's going on with that? And so the way that I would figure this out is I need something that puts this number, this really small number, into units that are a little more manageable. So what I'm going to use is I'm going to put this in a logarithmic scale, because the logarithmic scale is going to take these 10 numbers and make them more manageable, shrink it down. Okay? So because my concentrations can vary over a large range, we're going to use a log scale. So what we're going to do is we're going to start talking about the pH scale, which you've probably heard about before. So pH is equal to negative log of H plus or negative log of H3O plus, either one. Okay? So H plus or H3O plus. So if I have at 25 degrees Celsius, it's a neutral aqueous solution. Remember we said if it's neutral, what that concentration should be. We said that on this slide. So when it's neutral, my H3O plus concentration is 10 to the negative 7 molar. So I need to plug that in. pH is equal to negative log of 10, whoa, that's definitely not a 10, of 10 to the negative 7. This comes out to be pH, the log of negative 7. So if I do just the log of negative 7, that's a negative 7, because this log, what happens is this log and this 10 cancel. So if you take a log of a 10, they cancel. So when you take the log of something raised to the 10 to some power, you just get negative 7. So pH is equal to 7. So this is why when we talk about solutions being neutral, we say neutral solutions are at a pH of 7. So if they're acidic, then their pH is going to be less than 7. The lower the pH, the more acidic. So 7 is neutral, less than 7 is acidic, and the lower it is, the more acidic. Basic solutions are greater than 7. The higher the pH, the more basic. So higher pH, more basic. The higher the number, the stronger the base. All right, so let's look at this on the pH scale. So here's my pH scale. So right in the middle here is 7. I've got the H3O plus concentration, the OH minus concentration, and the pH. See how the numbers are that's a really big range? 10 to the whatever, where here it's just 0 to 14. So it's a lot easier to talk about if something's strong or weak. So 7 is neutral. If it's less than 7, all of these are acidic. If it's greater than 7, these are all basic. The lower than 7 it is, the stronger the acid. So like battery acid, that's really strong. Whereas like coffee, it's acidic, but it's not that strong. The higher than 7, so sodium hydroxide or bleach are strong bases, but some of these like detergents or even your blood technically is a little bit over. Those things are basic. All right, so let's do some practice.